Cool. All right, let's get into things. Today. Huh? Let's make sure, is this actually doing what I want it to do? Yep, it sure is. Restart that. I think it's been running all night, so probably a little slow. Okay, there we go. Good. All right, hope everybody's doing good. Feel free to bring your questions, post them in the thread. Any code that you have that you want me to troubleshoot, that's fine. Or if you just have a question about something, you can ask it. If you want me to explore a concept or go through a problem and learn, or just somewhere else, just provide a link so I can find it quicker. I don't necessarily know how to, like how to navigate straight to a given problem and learn just from a description of it. So, yeah, if you provide a link, I'll be able to find it really quickly, and we'll go from there. Cool. And I'm not seeing. Oops. Somebody says they got something for me. Great. Feel free and post it in. Feel free to post it in. Cool. Oops, we got the lag going on again. Ooh, couple questions. So this is number 3, and we've got some code coming, it looks like. Here it is. How does I set it? Cool. Okay, so let's do this. Oops. So here's the code that was sent in by the person asking the question. I'm just going to put a link up here just so we know where it is. Oops. And then challenge 3. Okay, and do I have the, yeah, that's challenge 3. Tuples containing multiple values, okay. Okay, write a function called tuples tupled info that takes 2 arguments. The first, called list, will hold a list of values. The second, called find, will the second called find is the value to find. Oh, I think I just helped somebody with this just the other day. I believe. Okay, cool. This function should return a tuple containing the value. Let's just do this. Return a tuple containing the value that was supposed to be found. Okay, and let's just sort of bullet this. So 1 is the value that was supposed to be found. 2 is the number of times it was found. Yeah, I did just help somebody with this. And a list of the indices where it was found. The values should be returned in the tuple in that order. Okay, cool. So val found. So there's a few things. There's a few super easy things And before I look through this code, so I notice we take in find here, and then we're returning val found. So when I start on a solution, I'm just going to pretend that I'm just starting. I'll come to this code in a second here. Let's say I've got some tests here. So I've got some tests or whatever, dirt tests. And I've got my function head. So the first thing I'm going to look for is like anything super easy that I can check off with almost no effort, or just things that I can just get out of the way that are basically spelled out for me. That and then potentially edge cases. So in this case, the value that was supposed to be found is the parameter find, right? So we can just check that off right away. Return find, just like that. Yeah, so that's one thing, and something to keep in mind here. So I notice return val found is actually a list, and let's see what we're doing with the list. So val found.count. Yeah, so Python being a dynamically typed language makes it like visually approachable and kind of aesthetically simple and nice. It means that there's less to learn. You don't have to explicitly you don't have to learn how to explicitly supply type information as you do with other statically typed languages. So it's nice. I mean, it has like there's a little less that goes into like putting together valid code. But one thing, so when I learned my first statically typed language, I instantly found out that I couldn't do anything without being aware of the type of everything that I was working with. So every variable and return value and method call, everything. Like I had to remember not only what it was, not only its name, and like what information that was supposed to represent, but I had to like train my brain to explicitly keep track of the type of everything. I know this is a little bit of a tangent, but um, when I learned my first statically typed language, I was like, oh, this is I like actually prefer static typing as a language feature in general. I mean, there's not that there's really a better way. It's just different. Um, but I really liked that way of thinking, and I thought probably the most valuable part of it is the way it trains you to think, to never lose track of your types, right? So in Python, since that's not enforced, um, I encourage people to like do it deliberately. So every time you see something that might describe a data point, think about what's the type of that information. Sometimes um, it's explicitly given, and sometimes it's I'll use the word arbitrary, which we can use the word arbitrary to mean any type. Sometimes we don't know the type. Um, so in the case of this is to return a tuple containing the value that was supposed to be found, which is find. We don't know the type of it, but we know it is whatever type was passed in here, right? So if we're returning a list for this, I mean, if val defined or if find was a list, then I guess that could work. But yeah, so you might have to do some juggling to make something like this work. And in this case, you can just shortcut it by just doing find right out the gate. So that's something that I think is worth mentioning. Just like anytime you look at a new data point, a new variable, anytime you're writing a function call, think about what's the type, what's the type, what's the type. And if you train your brain to do that, save you work down the road. Okay, cool. So that's one issue. So I'll just put a comment there just so I'll remember it. Then the number of times found. So there's actually a really quick and easy way to do this one too, and I see that count is being used. So we can actually, for the number of times found, we can do list.count find, just like this. And that's the number of times find occurs in the list. Um, I, I, I see a lot of people solving this problem without using count here, and I think it's because it's like, I don't think it's because people don't know about count. I think it's like, oh well, I want to go do the counting. So like, how would I do the counting? Which is fair. I mean, you want to learn programming, so you're going to do some programming. Don't want to make everything take the easy way out all the time. And until you know how to program, and then you're going to be like, oh, give me the easy way every time, because it's nice. But just to honor the what I see as the fairly frequent desire to like do it yourself, let's do it that way. So let's have a count. We'll say count equals 0, and if I wanted to count these manually, we'll just start our counter at 0 like this, and we'll have a loop and go from there. Okay. And then a list of the indices where the element was found. Okay. So anytime you have a problem and you think, I need a loop, and inside that loop you think, I need the index of something that I'm looping through, the answer is enumerate. You need to write a loop with enumerate, right? So I see what's going on here. And so we've got for value in the list, and this is going to give us each value, each element in the list directly, and then the index in the list. The problem with doing this is, well, for one thing, this is not going to give us the index just because it's called IDX. This is just a different name for the same thing, right? So in general, we'll call index IDX, but it's not like a special name that means it's that like necessarily like makes it the index. These two loops are exactly the same. So if I do, well, here I'll just copy them into mine. If I do this, and we'll just print val. Also, I don't mean to put you on the spot too much. You've got a lot of good thinking going on here too. That's worth mentioning. Kind of got the elements, and now it's just a matter of bringing them together. So, IDX. And also, I hope I'm not talking down to you because I don't necessarily know what you know, what you do and don't know. So, cool. So if I do this, like we should see essentially the same code echoed twice, right? We should see the same values echoed twice, but of course I need some tests. So I'll just comment this out to be clear that I'm testing the previous one. So let's do, does this give us tests? It does not. Okay. So a test is pretty simple. While you're working, I reckon, it's almost always a good idea to have at least one test going. So I'll call this my list equals a list, and and then let's have some. We'll do 55 here. Okay. So my list and 55. Oh, you like being on the spot. You appreciate the support. Okay, cool. Good. I will I will roast you. No, I'm just kidding. I'll be nice. But cool, good. I'm always a little worried, like, I hope this is actually helpful for this whoever's asking. So, all right, good. I'm glad. Seems like this is useful. All right, so I've got my test here. I've got some test data, and I'm just going to break this out just so that this line doesn't get too super long. And then I'm going to look for 55. So I notice 1, 2, 3, 4 55s in here. So what this should return is going to be a tuple containing 55, which is the element that I'm looking for, the number of times that it occurs, which is 4. Did I get that right? I thought I did more. 1, 2, 3, 4, whatever. Okay, 4. And then the indices. So that's going to be 1, 2. So a list of the indices. 1, 2, 3, 4, 5, and 6. 7, 8, 9. Okay, so and 9. So this is what I expect for this specific instance. This is what I expect. So if I print val for val in list, print val for IDX in list, print IDX. Let's just be clear about this. Let's do this. Oh no. Oh no, 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 no. Okay, there we go. Actually, don't need that space there. There we go. So this will mark val with the string val and IDX with the string IDX. But we'll be able to see if my, the lag, oh my gosh, the lag, okay. It's a little crammed in here, right? But, if we just take a little section, val is 33, 55, 44, and then 11. And if we come down to IDX, 33, 55, 44, and 11, right? So all that's happening there is we're just giving that identifier. So it's essentially a variable name. The name part of a variable is what I'm referring to as an identifier, right? So we're just giving that a different identifier, but it's the same exact behavior, right? So if we wanted to do just the index, we could do this, range len. We could do range len, and this will give us the index. This will give us just the index. So there's still a problem with this. So let's just look at the output here. All right, so val is now the element, so we loop through all the values, and then let's come down here, and then we loop through all the indices. Okay, so now we've isolated the correct value and the indices, but the problem is we loop through all the values, then we're done looping through values, then we loop through the indices. So we need the indices associated with the values. So what we can do, like I said, enumerate. That's the key. So we can enumerate. And let me see about this. Let me see if I can just like that. Okay. So now this is better. So val 33 is located at index 0. Val 55 is located at index 1. Like all this really needs now is a condition and an append, or maybe a couple other little touch-up things, right? But we already have, you can see, 55 is the number we're looking for. It's at index 1. 55 again, here's 55 at index 5 and 6, 55 at index 9, right? So from here, it's sort of just downhill. It's just smooth sailing. So let's just get rid of that. It's made its point. So from here, I can say if val equals find, count plus equals 1, plus equals 1, and what did I want to do? I wanted to oh, the IDX list equals a list, and then so we'll say IDX list. Oops, jumping around there. Sorry. Oops. IDX list dot append IDX, and then we're going to return find, count, and IDX list. There we go. Okay, so 55,41569. 55,41569. Cool. So that matches our expectation. That's good. So this is the manual count approach, like where we're just literally incrementing the counter every time. Like I said, there really is a easy way to do that, and I do find this preferable, but just for the sake of doing it, we can do it that way too. So I would find this preferable because this is just so easy to determine right out of the gate. You know, like we can determine the number of the number of times find occurs in list just like this. So that's nice and easy. All right, and I will submit it into Learn just to verify that it works. Come on, come now, come on. Is that not gonna, okay, all right. All right, let me know if you have any follow-up questions for this. I'm gonna take just a look through, see through your code here, see if there's anything else that jumps out at me. Let you get. There's a bit of a lag between when I speak and when you hear it, and then so I will give you all a second if you have any follow-up questions, and then I will jump into the next question that was asked. So val defined, we turned into just returning find itself. Times found. Oh, you were doing a list here. Okay, so I should mention this. I'll do this with the times found thing as well. Times found list. Okay, so if I was going to use times found, I could do times found dot append IDX, and then take for count. I could do oops len of times found. That would also work. I could just append to it, append what it, like literally anything, like it doesn't even matter what it is. Could just do that. So that would be another variation on that. Cool. And then indices, we already went through that bit. All right, cool. Yeah, we'll just leave that there. Okay, I will move on to the next question. Oh. Copy link. And we'll go to, I'll just reuse this one. Okay, so dictionaries, and this is question, dictionaries 1, challenge 19. So the person asking this question, if you have any code, any particular questions about it, feel free to provide that. Otherwise, I'll just go through a solution. Number 19, okay. Is this number 19? Challenge 19. Okay. Let's get these ones. Looks like we got some tests. Are those? No, those are good. And we've got a function head given for us. Okay, so get elements that are equal to 10, that equal 10 at a value. Okay. D sub, oh, excuse me, obj sub key. So, this question, I think this is an old question that's been around. I thought we had retired these ones. This was written by somebody that was, I think, a JavaScript programmer, and they were calling dictionaries objects, which JavaScript, so Python does have objects as well, and they are technically the same as JavaScript's objects, although JavaScript weirdly, and this is really unusual, I don't know if any other language has a type literal for objects, but JavaScript does, and it looks like a dictionary. JavaScript doesn't have JavaScript's key value pair type is an object, and it's also an object, or like what Python would call a class. So it's a very different kind of type, although it fills the same role that Python fills with a dictionary, essentially. So you get JavaScript programmers learning Python, and they view dictionaries as objects until they learn what objects actually are, and they're different than how they seem in JavaScript. So this is kind of a funny problem that this is still here. So let's just do this step by step. Return d sub key, and this should give me okay, so for this one, this is interesting. If the type of the key is an integer, so here notice this is back to like paying attention to types, right? Having worked in statically typed languages, I instantly recognize that this is a dictionary of string list of numbers, list of integers, and this is a dictionary of string int, right? So the type signatures of these dictionaries are different. And even though this element is 10, we expect an empty list. So I think what we can do is to just say if type, it's probably kind of like a smoother way of doing this, but I don't know. If type obj sub key, I hate calling it obj, so I'm just going to call it d. If type d sub key equals list, you know what? I'm going to say not equals list, return empty list. We'll do that. So we'll just treat that as an edge case and handle it up front. Otherwise, we can return the d sub key dot count 10 and just multiply that by a list with 10 in it. Which is I'm kind of circumventing writing a whole accumulator by doing this. I'll show an accumulator solution as well, but I think this will work. Okay. And then I just want to try it without, I'm almost certain this is going to give me an error without the edge case. It does, yes, because int object has no attribute count. Okay. There we go. Okay, so let's see if this works. I'm kind of expecting this to have some weird tricky thing. And yeah, it does. Of course it does. Key error key. Key? Did I say? Oh, I didn't. So what's the problem? Okay. Key error key. So what does it want? Oh, you know what? I should probably actually read the full problem statement. That's what I didn't do. All right. All right. All right, you got me. Okay. So if the list is empty, it should return an empty list. So if it's not a list, if the value at the given key is not a list, it should return an empty list. Okay, so looks like we have a few conditions. Yeah, so if I do, all of these should return an empty list. Okay, so if it's empty, we should get an empty list. Let's try this. Empty list. I think this should just work on its own. Nah, it's not gonna. Oh, like I said. Okay, so that does work on its own. That's nice. If the value at the given key is not a list, return an empty list. We're handling that as an edge case. If the list contains no elements that are equal to 10, it should return an empty list. Okay. If the list does not if the key does not exist, okay. So in this case, let's use dot get dot dot get key in this case, I'm going to use a ternary. I'm going to do this if key in d dot keys. I know I don't need to do dot keys there, but I like to. Else empty list. Okay, and then this is for the case where the key doesn't exist. This should of course be an empty list. Okay, so we're still getting a key error. All right, I'll do it the non-fancy way. Okay, if key in d keys, return this. Else return empty list. There we go. Oh, I'm being silly because, yeah, let's just do this. So I'm getting that key error way before, right, I didn't pay attention to the line number. That key error is actually happening right here. So, okay, we'll do this. Oops, like that. Okay, so if key and D keys and, or we could do or here. Yeah. That's just a simple problem that I just screwed up by not reading the the notes at first. Okay, so if key not in D keys or type D sub key not in list, we could say, or list yeah, D sub key is the list equals empty list, or ten not in D sub key, then we'll return an empty list. I don't think we need this last condition here, but I don't know. Kind of feel like being exhaustive since it's saying that. All right, now let's try it again. Okay, cool. So something interesting here, if and you can lay out, so real quick, I'm formatting my conditions like this. This is something that I like to do, rather than have like a really long line of just with this sort of gruelingly long condition here with like multiple ors in it. You know, this is kind of an annoying line of code, whereas this is kind of a nice line of code, or kind of a nice few lines of code. You know, it's kind of simple, and I'm justifying everything like this, or just straightening everything out like that because I don't know, I like the way it looks. The backslashes, by the way, allow me to just put in a line break artificially, and Python will just ignore it. It'll pretend like it's on the same line, so it'll allow me to spread it over multiple lines. It's something I like to do. It's not something that you have to do. You can put it all on one line, but this makes it easier for me. Okay, so interesting thing here, right? D sub key will throw a key error if the key is not in the dictionary. But we can, if we check this condition first, right? And since we have ors here, it'll say if key not in D keys, it won't even check this line if the key's not in the D keys, because this condition's already been determined to be true. So since these are ors, we don't need to check the other conditions. We already know that we want to jump into the body here. So it'll just totally ignore that. So this is, you know, in the case that we supply a key that isn't in the dictionary, this line would give us an error, but it's sort of protected by this line. So that's why I put it first. In this case, it does matter which order it goes in, right? So I can't get away with doing this. Like doing type D key, you know, doing the potentially doing the thing that may potentially give me an error here, D sub key. Uh, so it's not going to be okay doing this because, you know, key not in D's is checked after we try to access the key in the dictionary. So has to be in that order in this case. Yeah, like I said, that should work. So let's submit it. Okay, there we go. Cool. I'm trying to think of any other notes on this one. I think this is good. Feel free if you've got a question about it, just pop it in. It looks like we've got a few more questions, which is great. A lot of activity today. Appreciate it. Excuse me. Oh, and we did have some. I'm sorry. The person who asked this question did have some code. Let me just pop it in here, and we'll see. Okay, so we have a new list. If not object key. So, okay. Return new list. I see. I see. Um, so this will work if the list is empty. Oops. This will work if the list is empty, but not if the key is not present. So we have to, you have to handle that in some way. So I wonder if you could do, yeah, I mean, you just have to handle it one way or the other. You could say, if key not in obj. I mean, basically, I'm just turning it into what I just did. I'm trying not to. I'm trying to like do it your way here, but I don't know. That's I'm doing it my way. Okay, so if key not in obj or not object sub key, this is tantamount to saying if object sub key equals empty list. Let's try that. Let's see if that'll work. Int object not iterable. Oops. This should be a not equals, not a. I was like, I should have just handled that right here. Oh, and also, what am I doing? This should be equals, and then, okay, right. Then we need to type check. So we need to say or type not equal to list. Okay, so no errors. It looks like this works. And then this is a more conventional accumulation. So let's see, if or. Yeah, so we can get away without doing this last one, without doing that fourth condition in there. And I mean, my personal preference would be to just return an empty list just like that. But I don't know, either way. Then you could just save yourself a couple lines. Doesn't really matter here. I mean, continue or do it this way. But that might be maybe a little nicer. I don't know, a little cleaner. And this is good because I forgot, but I meant to show the accumulator way, and I was doing this sort of repetition way where I'm multiplying a list with 10 in it by the number of times that 10 shows up in the list. So, but yeah, the accumulator way also makes a lot of sense. And just to be clear, let me submit that. Let's see if Learn likes it. Likes it. Okay, cool. On to the next question. Challenge 3 in. We're about to find out open-ended problems. Oh, I have that. I think I have that up. We'll just go to it here. All right. So, to the person asking about challenge 3 in open-ended problems, yeah, if you have any code, feel free to send it in. If not, that's fine too. And I'll just start going through it. Twin prime. I remember doing this one recently. I think I had fun with this one. Oh, also, you're welcome. Yeah. Okay, twin prime. So the twin prime conjecture is a theory in which there are an infinite number of pairs of prime numbers that differ by 2. This function finds the nth twin prime pair, for example, the 5th twin prime pair is 29. Okay. Cool. So twin prime. So, okay, sorry. I just launched off in my, I was like, what do we need for this one? I got excited there. Okay, so let me back up. So for example, the 5th twin prime pair is 29 and 31. Okay, so this gives us a, essentially a test. We can use this as a test. So twin prime, print, twin prime of 5 should give us this. And let's do, oh, I don't know, I was gonna do 1, 2, 3, and 4 just to kind of get a sense, but I don't know, that sounds like not a great use of time right now. Okay, so parameters, we'll take in an int, which will be the nth twin prime pair to find, and we'll return a list. So actually that's got to be a list. The nth pair of twin prime numbers as a list of 2 integers. Okay, so this will be the 5th one. And we'll reverse engineer the other ones here in a minute. So in order to know if 2 numbers that differ by 2 are twin primes, we need to be able to determine if 2 numbers are prime, or if a number is prime. I could write this, like all this logic in here. It would involve like it would involve a bit of like, to me, it would feel like variable juggling, where I'm kind of like moving Boolean flags around and things in loops, and I just find it much easier to just break out logic into functions when I can. So we're going to need to know, we're going to be able to, we're going to need to be able to, excuse me. Okay. We're going to need to be able to determine whether or not a number is prime. And one way we can do this is if I write a next prime. If I write a next prime function, so I'm going to use isPrime to write next prime. If I write a next prime function that takes in a number and gives me the next prime number, I can say in here, I can say if I can loop through numbers. Here, we'll write out this code now. While true. Oh, we don't want to do 0, do we? We'll do 2. Okay. So I equals 2. Well, we'll do I equals 1, and then I plus equals 1. Oops. Then we'll say if is prime I, and then if next prime I minus I equals 2, right? So if I is a prime number and I should do this, and the next prime number minus I equals 2, then is prime I, or excuse me, then I, which is prime, and next prime, which is also prime, differ by 2, which means they're a twin prime. So I could do twin primes equals a list See, this is interesting because is 2 and 3 considered a twin prime? You know what? I kind of think it is. I'm just going to assume that it is, and if things get weird, then I'll reassess that. So we don't want to start at 2 or 3. We want to start at 4. No, we want to start at 3, which means we want to start at 2, and we'll increment immediately to 3. Okay, while loops. So under this condition, we'll append twin primes dot append. We'll append I and next prime I. So remember, is prime. So I was talking about earlier, right? This might look a little funky. Might be like, well, why not append? Why not append is prime I? As I'm doing this, I'm hearing the voice of like, why don't these two things look the same? Like, why I in one case and the next prime? This is what I'm talking about like having learned a statically typed language. And I don't think you have to go learn a whole different language in order to train your brain to think this way. It's just that, you know, it didn't become apparent to me how important it is to keep track of your types until I learned one. But it could be. You don't have to go out and learn a whole different language other than Python. So always keep that in your mind, right? Like what are the types? Like is prime and next prime look similar. Is prime takes in a number and tells you true or false. It gives you back a Boolean, true or false, whether it's prime or not. Next prime's a little different because it gives you back for a value of I, it gives you back uh, the next prime number, right? So that literally gives you back, it takes in an integer and returns an integer. Is prime takes in an integer and returns a Boolean, right? So we want to, if we've determined that I is prime, I is the number. If we've determined that the next prime number minus I equals 2, then we've determined that that is that I and the next prime number are a twin prime pair, and we'll append both of them like this. And we actually want to append them as a list. Okay, cool. So now I need an exit condition. So I want to say if len of twin primes And is this, oh, I just named my freaking accumulator variable the same thing as my function. Okay, we gotta fix that. We'll just call it twins. So if len of twins is, I'm just gonna do greater than or equal to, what is this, nth? Nth. Return twins sub -1, just the last, whatever the last element in twins is. Okay. All right, I just ran it like I'm going to test it, but we haven't defined is prime and next prime yet, so we're going to get an error. All right, so let's do this. Is prime, this one's a good one. So is prime, we can take in, oops. I'm like, why aren't we getting that error? And then I'm like, well, we have a while loop with without a break in it, and it's going to run forever. Cool. We'll just break it like that for now. All right, is prime. By the way, I do stuff like this that's like temporary. If you're wondering why I left those comments there, it's just so that it'll stick out. And I'm just like marking this line as like, this is just something that I do to just be like, yeah, I'm gonna delete this later. Just like throw a string of comments on it, a row of comments on it, just so it kind of sticks out. And I'm like, oh yeah, I need to get rid of that. So that way, when I come back here and I'm like, all right, let's test everything, and it's not working, I'm not like, why isn't it working? And then I have to remember that I put in a break up there, which is, out of fear of doing that, I'm like, I better remind myself. I better put something there that'll make it obvious that that needs to go away again. Okay, cool. So is prime. So if n is less than 2, it's not a prime number. So we'll return false. And we'll say for I in range 2 to, we can actually do the int of the square root of n. And there's so many parentheses. So where do I want to do that? I want to add, and I want to include it. So we can reduce the number of numbers that we need to check, number of iterations in our loop here. Okay. Let's spread this out just a little bit. That's nice. Okay. That's a little clearer. That's 2. We'll do 3 there. Okay. The extra spaces are just to just give things visual relief. They're just there for aesthetics. And it's a me thing. It's not a Pythonic thing. Just so you know why I'm doing it. You don't have to do it unless you want to. I find that with my dyslexic eyes that get confused by characters crammed in, I know it's ironic that I became a programmer, but that kind of thing helps is the only thing. Okay, so for I in range 2 to the square root of n inclusive, we can say if n mod I equals 0, then we can return false because we know we found a factor of n that tells us that it's not a prime number. Otherwise, if we make it all the way through this loop without returning false, we can return true. It is a prime number. I'll just button it up. Nice, compact, succinct little is prime function. Okay. I do feel like testing it though for I in range 20. Print I and is prime I. Okay. We'll just see real quick. Give it a quick look-see. Make sure we're getting the right answers. Oof. Oh, I wasn't scrolled down. I was like, what's taking so long? Okay, so 0 and 1 are not primes. 2 and 3 are primes. 4 is not. 5 is. 6 is not. 7 is. 8, 9, and 10 are not. 11 is. 12 is not. 13 is. 14, 15, 16 are not primes. 17 is a prime. 18 is not a prime. And 19 is a prime. Good. Okay, so that appears to be working at least for those small numbers. If there's a problem with that algorithm, I don't know about it. Okay. So next prime. So we can do a while. I'm going to do a while true again, like my while trues, and then I'm going to just reuse our input here. Now, for some of you, you might go like, well, aren't we not supposed to mutate our inputs? The answer is yes. Don't want to mutate the inputs. But this is an integer, so it's not a mutable type. So we can't mutate the input. So what mutating the input means is that if I had my number equals 10 and I print next prime of my number, right? Whatever happens here, like if this were a mutation, it would change my number, right? It would change the my number, right? And this should return 11. So, right, my number might return 11, but that's not possible in Python because ints are not mutable types, right? So this is not a mutation. This is not like appending to a list is a mutation, right? If we took in a list into a function and didn't copy it and altered directly on the parameter, it would change the value that we passed to it. It would literally change that value. So that would be a mutation. So this is a safe operation. It's not going to cause any change to this number outside of this function. And since I don't need to use it for anything else, I happen to know that I can get away with doing this in this particular case. So I'm going to do it. So n plus equals 1. Incrementing right away, and I've seen people do this, counter equals n, this sort of copy thing like this, something like that. But however you do it, incrementing right away means we're not going to check n itself. That way, say n is 7. We don't want it to return 7. We want it to return 11, which is the next prime number after 7. So this prevents us from checking n itself. So we'll n plus equals 1, and then I'll say if is prime n, return n. Nice and easy. Cool. Looks like we have a question here. 2 and 3 are not a pair as there needs to be a gap of 2. Okay. 3 and 5 are the first pair. Okay, cool. Thanks for that. Yeah, so I wasn't sure. So this is just a comment on what the first pair of twin primes are, which I guess is 3 and 5, which I wasn't sure about. So I will do that there, and we'll start this at 5, like that. Okay, cool. So that's just our test. Yeah, let's just test it. We should get 11 after this. We'll be good. I'm going to kind of cinch this down like that. That's nice. Okay, there's our 11. All right. I like this problem. I'm having fun, if you can't tell. Return twins minus 1. Ah, well, see, that's interesting. Oh, I see. eh, I, I looked at this and I'm like, but I wrote this logic first. Why isn't it working? Why am I getting none for this function? And remember, it's because this break. See, I even left the bar of comments and I forgot the break, right? Um, but as soon as I was like, oh shoot, I got to look at the code because I thought I wrote it all out, and then I saw the bar of comments. So even though I gave that spiel, if I had left it off there, I wouldn't have seen it, and I'd probably still be going, why isn't my code working? So okay, 41 and 43, which is not the answer we were expecting here. And oops, oops, oops. I want to do 4 here. That's what that should be. That may change the answer. 29 and 31. Okay, cool. So I was starting at 5. I didn't want to increment. Well, okay. I was starting at 5 because I'm thinking, okay, well, 5 is a prime number, so it could be. It's also the lower of a twin prime with 5 and 7, right? So 5 is a twin prime with 3 and a twin prime with 7. So in this case, we have to start at 4. That way we immediately increment to 5 and go from there. You might ask yourself, well, like why not start at 5 and increment at the bottom? the, the reason I lay out my while loops the way that I do, so I have this rule of thumb. I'm not necessarily going to die on this hill as like the way it has to be. But when I when I first learned Python, or my first attempt at learning Python was in a college class that was structured pedagogically very differently than I structure uh, the way that I teach. And before, it was this sort of attitude that's pretty prevalent in most conventional comp sci approaches, um, which is, like you teach people the hard stuff first, and then they got to like earn the easy stuff. And that's not an attitude that I subscribe to either as a learner or as an educator, but that's pretty typical in those spaces. So the idea was that they taught us while loops without teaching us for loops, and like all our loops had to be done with while loops. And I mean, while loops are powerful, you can do a lot with them. But I just became like traumatized by like all the every time I'd write a loop, like I get scared because I'm like, it's like I know it's gonna get into an infinite loop, and I just start to feel this anxiety about like my I had this little netbook that would just get so hot if I got into an infinite loop, and a couple times I just had to like I didn't really know what I was doing back then. I just had to like reboot my computer because it would become unresponsive. I was really just starting out. So, anyways, as a rule of thumb, I was like, okay, whatever I'm using to control my loop, I'm gonna put it right there up in the front, right there where I can see it, so I know it's there, so I know it's doing its job. And to this day, like I just do this out of habit when I write a while loop. It feels wrong to me to not have whatever I'm using to control the loop or whatever I'm incrementing right up front with that while loop. So I try to group everything kind of as tightly as close as possible. You can't always get away with that, but wherever I can, I'll do that. And if you are just starting out with while loops, that can be a good tactic for just making sure like you have all your boxes checked. That you have your controller initialized and your while true and all that, right? Your condition, that's what I meant to say. Your condition and then your control incrementation, whatever you're doing there. Um, so, anyways, to the hypothetical question, couldn't you just start it at 5 and put it at the bottom? Yes, although to this day I still like my gut turns a little bit when I write a while loop, even though I don't have a problem controlling them now. Cool. So let's actually submit this into Learn and see if it thinks this is a good solution also. And it might fail. That's okay. We'll read the errors and go from there. Ah, it did fail. Okay, let's see. 5 and 7, it was expecting 3 and 5, but it found 5 and 7. Interesting. So I wonder, I wonder if maybe I do need to, I don't remember why I did this initially. Seems like there was a good reason to start it with a first pair. So this should be for the test 1. 1 should give me 3 and 5. Yes, okay. I don't know why. I may yet find out, but let's see if that works. Okay, that was it. All right, little hitch. Nothing out of the ordinary. Will I put the code in Slack? Yeah. Okay. There you go. There's those. All right, and it looks like we've got another one here. This might be the last one that we have time for today, although, yeah, you're welcome. This might be the last one we have time for today, but if anybody does have another question, feel free to get it in there, and I might have time to sneak it in at the end, depending on how quickly this one goes. So go ahead and put it in now, so I know you staked your claim, as it were. Let me do this. All right, I just want to document this. And then this next one is for question 3. It's always question 3. Okay. Replace. Okay. Replace doubles. Ooh. Ah, yes, yes. Replace doubles. The old replace doubles function. Indeed. Okay. So let's do some tests first. So this, okay, so write a function called replace doubles. This function takes a sentence as an argument and checks for any double letters, for example, AA or TT, and replaces the double letters with just a single instance of that letter. So double A turns into A, etc. Notes this function should be case sensitive. So be sure to preserve the case of each character. Also, capital A, lowercase a should not be considered a double. The space character may also be doubled and should be replaced by a single space. So we want to check spaces too. Okay, so let's do some tests. My text equals, what should we call it? Excuse me. So let's just do some. Let's do something like this. We'll have a double H. The LL is going to go. Let's have a double space and R W O R L D D. Okay, so for this, we should expect. Oops. We should expect a string that's like this. Okay, cool. I think that kind of covers it. Okay, cool. Let's just go from there. Def, replace doubles, takes in, I'm just going to call it text. And, okay, so there's a really cool way to solve this problem. Okay. So I've got a lowercase alphabet and an uppercase alphabet. Notice I snuck a space in there. Remember, we want to check spaces as well. So here's the thing. I'm going to say for character in ABCs. And this is one of those things, like sort of the a bit of the art of the accumulator. You know, this is a tricky spot that's easy to overlook. Like, what are you iterating through? What could you be iterating through that could help you solve a problem? So I'm going to say, I'm going to call this underscore text for input text. And then I'm just going to call this text equals an empty string. And we'll say text plus equals, oh, wait. Oh, no, I don't even need to do that. I'll just reappropriate the input again. Then I'll say text equals text dot replace C. So text dot replace C plus C. So double C with single C. Return text. This is a tricky way of solving this. And we'll see. We'll see what happens. Hello world. Okay. And let's submit it. Make sure it works. Oops. Correct. Okay. So this is a weird one. This is a weird solution because we're not, you know, we have this thing that we could iterate through that we're not iterating through. So this is very much I think this is a very elegant solution, but it's very much a curveball. Um, so let's look at I want to look at just to show that this problem can be solved uh, with uh, slightly more conventional means. So let's do. There's kind of a weird, if I remember correctly, there's kind of some weird juggling with this one. I'm going to say, all right, let's call this res. I hate doing this underscore stuff. So text is our input and res is our output. We're going to return res for character and text. And I think we're going to have to enumerate. And we'll say I and C for character. And then let's do P for previous character equals text sub I minus one. Oops, minus one, like that. Okay. The first iteration, though, we're gonna get the very first iteration. I minus one is gonna be the last item in the list. So we don't want that. We want since we're checking 2 items at a time, we want only we want to skip that very first iteration, basically. So I can say if I equals 0, we'll just continue. So we'll just continue through that very first iteration. Otherwise, we'll go on with our regular logic. So now I'll say if P equals C, do I continue here too? I think I do. And I think or P equals C, I'll continue. And then let's see. Res plus equals C, I think in that case. I feel like I'm doing something wrong, but we'll figure it out. We'll see what this output has to say for itself. Hello, world. Okay, so I didn't get my H in there. That's right. That is right. So let's see if I add in P. I think I'm not going to get the last element in there. Yeah, okay. So I'm just going to get around this by saying if res sub -1 is not equal to C. Notice how I'm outside the loop here. I'm doing this after the loop is over. So if the last element in res is not equal to C, then we want to add in C. So we'll say res plus equals C, like this. This is the juggling that I was remembering. I kind of use that term loosely, like when you're kind of like, I don't know, just like juggling to me seems like you're like sort of moving things around, maybe unnecessarily. That's not really what's happening here, but this sort of like, okay, well, after the loop is over, just make sure that the last element isn't duplicated, and if it's not, add it in. So let's try that. Make sure we get our exclamation point. Okay, and I'm gonna just do this. Oops, I took it from the wrong string. I want to do it from this string, just to make sure that we end up with one capital D there. Okay, good. So that appears to be working. So this is kind of a funky solution, but it is a pretty straightforward. It's straightforward in the sense of, empty variable, positive accumulator, sort of. We need to use enumerate and do this. I'm calling this P. I usually will call this previous. So sorry if that wasn't obvious. I'll usually call it previous and current, but that's why I'm doing this. But yeah, let's see if learn thinks it's a good solution, and we can go from there. Oh, did that run? I was looking away. Okay, good. So that solution works as well. You know, I show this solution because there's something obvious about it, even though it's actually harder. If you have the thought to iterate through the alphabet, look how friggin' easy this problem is. But it's just a matter of having the thought initially, right? But so whenever you write an accumulator, really give some thought to what am I iterating through, right? It's an easy thing to overlook. It's a part of the accumulator that you can overlook, but if you look through it, you'll see that it's easy. Anyways, okay, cool. All right. Well, I'm not seeing any other. Am I missing one? I don't want to miss any. This is in. All right. Oh, and you had code that you. I'm sorry, I totally missed that. There was some code that for me to troubleshoot. Let me just go look through this. Try to. We'll see if it can be solved like this. Okay, cool. So this takes in string, new sentence. Okay, so it looks like we have just two separate logic channels for logic, for uppercase and for lowercase. In this case, though, this transform is going to mean we convert. Well, we're going to iterate through the string. Yeah. Let's see. If string dot count char greater than 1. Yeah, okay. So now I'm wondering, might be able to do this. Okay, so if string dot count char greater than 1, this will be, this is a weird one. String equals string dot replace. Yeah. Okay. Char. Let's do char plus char with char. And we don't want to do necessarily if the count is greater than 1. I think we can just do this. We don't even need that. Well, that might work just on its own like that. You know what? In fact, I think it will. And then we don't even need to iterate through the alphabet. Oh my gosh. Well, this is my new favorite solution. If that's going to work. I have my doubts, but we'll see. All right, so joke's on me. So we can just iterate through the string, and that's a nice simple solution. So it's sort of a combination. Saves us from having to make this weird ABCs variable like this. Yeah, so we just go through, check every character in the string, and then reassign string equals string dot replace double char with single char, and that'll work as well. Cool. So it looks like you were on to a pretty good way of thinking about this. Yeah, it was just a matter of like how replace works. We can just reuse that here, and then if you do doubles and lowercase, hmm, hmm. Or excuse me, if you do upper and not doubles and lowercase, uppercase and lowercase, if you have two separate channels for logic for that, um, you're going to artificially, you know, iterate through something that's all uppercase and then all lowercase. So you're going to actually lose um, casing information from the original string, which you want to preserve. So, but other than that, there's the kind of the route that you were thinking about this um, is pretty cool. That's my favorite. This is canonically my favorite solution yet. This is way simpler. I was like, see, always pay attention to what you're iterating through, and then right in front of me, right in front, it's so obvious now. I'm like, oh, I could have just done that, and that would have been way easier. I think I actually have thought. I forget things so quickly. I really do forget things. Like, I'll think of a really cool solution, and then help somebody with the same problem like 2 days later, and I was like, ah, there's a really cool way I did this, and I can't remember it. So, and then I'm gonna do this because that's what I do. TXT. Okay, that's my favorite solution. Cool. All right, so we can wrap up there. Nothing fancy. Yep. We can wrap up there. Um, hopefully everybody enjoyed stream today. Seems like a pretty lively stream. I found this stream. I always enjoy streaming, but this was a lot of fun. I really appreciate it when y'all get your questions in there and interact. So it makes it fun for me, and I think it makes it useful for everybody else too. We didn't even go through any material today, which is great. All questions today, which is awesome. That's what I want. That's what I'm hoping study halls can always be. But so yeah, thanks a lot for everybody who interacted and brought in questions. Feel free to keep doing that. Keep bringing questions in for future study halls. Next one will be on Friday. If you want to show up for that, I look forward to it. So yeah, feel free to reach out to me outside of study hall times. DM me. I know it can take me a little bit to get back to folks, but you're welcome to DM me, and I will get back to you as soon as I can. So yeah, I shall see you all proverbially, as it were, on Friday. Cool. Have a good rest of your day. Bye.